Assalamu alaikum, I'm Dr. Wa'il Muhammad, PhD in Applied Mathematics from Egypt. Now we are going to solve Edexcel International A-Level Jan 2020 P1 paper. Okay, let's start. Number 1, find in simplest form. Okay, first we should put the integration in what we call integrable form, which means 8 over 3 x power 3 minus half. X will be power half in the denominator, but up we can write it negative half here, x power negative half, minus 5 all multiplied by dx. Okay, we are ready to integrate now. So we have x power 4 over 4, okay, 8 over 3 multiplied by x power 4 over 4, and then minus half. We will raise 1 to the power to be x to the power of half. Negative half plus 1 means half. To divide by half, it means you will multiply by 2, right? And then minus 5x plus c. Let us simplify this. 8 over 4 will be 2, so it will be 2 over 3x power 4 minus half times 2 will be 1 minus half x power half minus 5x plus c. Okay, 2. Given y equals 3 power x, express each of the following in terms of y. Write each expression in its simplest form. Okay, 3 power 3x. We can write it as following. We can write 3 power 3x as 3 power x all power 3, right? Because in this case we will multiply the power by the power to be 3 power 3x, and then replace 3 power x with y, so it will be y power 3. Okay, for b we have 1 over 3 to the power x minus 2. Okay, we can split 3 power x minus 2 to be 3 power x multiplied by 3 to the power of minus 2. Okay, because if you combine them again, it will be 3 to the power of x minus 2 as the question. And then it can be written as 3 power 2 divided by 3 power x. I raise 3 power 2x up with positive power and 3 power x as it is. Then it will be 9 over y. Okay, see, we can split also the denominator to be what? 9 to the power of 2 times 9 to the power of minus 3x, right? And then 9 power 2 is 81. So this 81 can be cancelled with this 81, and then we have only 9 to the power of 3x in the numerator, and 9 can be written as 3 power 2, right? 3 power 2 all to the power of 3x. Take care, the negative in the denominator is positive in the numerator, and then we can make it as following: 3 power x all power 6, right? You know that we will multiply powers together, 2 times 3x, so it's the same as 6x like this, and it will be y power 6. Okay, question 3, figure 1 shows part of the curve with equation y equal x squared plus 3x minus 2. Okay, the point P 3 and 16 lies in the curve. Find the gradient of the tangent to the curve at P. Okay, super easy. We can get the derivative, of course. To find the gradient of the tangent, we can differentiate it. We can find y dash to be 2x plus 3, and then at x equals 3, the gradient of the tangent at P will be what? Will be 2 times 3, 6, 6 plus 3, 9. Okay, the point Q with x coordinate 3 plus h also lies in the curve. Okay, Q also is in the curve. Okay, B, find in terms of h the gradient of the line PQ with write your answer in simplest form. Okay, very good. Simply to find the gradient of a line PQ, we need to know the coordinates of point P and point Q, right? Point P is given, but what about Q? We know just the x coordinate of Q. At Q, x equals what? Xq equals what? Equals 3 plus h. Then the required is to get yq, which is f of 3 plus h, right? Which means replace x in the function here and put it 3 plus h. So it will be 3 plus h all squared plus 3 times 3 plus h and then minus 2. Okay, it will be 9 plus 6h plus h squared and then plus 9 plus 3h minus 2 simplified to be h squared plus 9h plus 16. Okay, then we can find the gradient very easily. Okay, we can write mpq equals yq minus yp divided by xq minus xb, and then we can substitute to be h squared plus 9h plus 16. All this expression is the y of q minus y of p to 16, and then xq, which is 3 plus h, and then minus 3. After simplifying it, it will be h squared plus 9h, h squared plus 9h divided by what? Divided by just h. And if we simplify it again, it will be h squared over h to be h, and then plus 9h over h, which is plus 9. Okay? C. Explain briefly the relationship between the answer to B and the answer to A. Don't forget to know the answer of A was what? Was 9, right? The slope of the gradient of the tangent at P was 9, and the tangent of PQ is h plus 9. Okay? To explain this, look at the figure. Okay, suppose that this is the x coordinate of P, which is 3, and suppose that this point is Q with x coordinate 3 plus h. So this part is just h, okay, and this point is 3 plus h. We can say that as Q approaches P or tends to P, okay, as h tends to 0, and the secant, which is the line PQ, will be very closer to be a tangent. Okay, again, for Q, as Q approaches P, this line will not cut the curve into 2 points, but it will be a tangent at P because Q will coincide on P. Q will be on P. So we can write the following. We can write here as Q, simply as Q approach to P. This symbol mathematically means that Q will be on P. What will happen in this case? Do you remember H? H will be approach 0, right? Because H is the horizontal distance between P and Q. And in this way, by this way, PQ will be a tangent at P, right? Tangent at P, and so that the gradient of PQ will be the gradient of the tangent. And if you put h equals 0, if we put h equals 0 in MPQ, it will be 9 as the gradient of the tangent, right? In this result, if we put h equals 0, the gradient will be 9 as the gradient of the tangent at P. Okay? 4. Figure 2 shows the plan view of a house ABCD, A, B, ABCD, A, B, C, D, okay? And around ABCDA. ABCD is a rectangle with AB 16, APCOA, APCOA is a sector of a circle center O with radius 12 meter. Of course, we can get the length of the arc AC, APC, and we can get the area of the sector and so on. Okay. The point O lies on the line DC. Okay, as shown in figure 2. Show that the size of angle AOD is 1.231 radians into 3 decimal places. Okay, very simple question. But first we should put this data on the in the diagram. The radius of the sector is what? 12. So we have here 12 meter, right? And this rectangle has AB equals 16, right? AB equals 16 meter. This is rectangle, so that AB equals DC, and so that this OD will be 4 meter. 4 plus 12 equals 16, right? Also, we have that OA is radius. OA is radius, so that its length is 12 meter. For this angle, for angle A, for triangle ADO, we know the length of OD and the length of the hypotenuse, so we can get this angle easily. Okay, by getting cosine inverse 4 over 12, right? So we'll write cosine inverse 4 over 12 to be equals approximately, it will be 1.231 radian. Okay, the line ABCDA is shown shaded in figure 2. B, find the area of line in square meter to 1 decimal place. Okay, now we have this angle, right? If we add pi to this angle, we will get the angle of the whole sector, right? Of the whole sector. So we can get the area of the whole sector and subtract the area of this triangle, right angle triangle, from it to get our answer, right? Let's go. So the required area equals area of the sector minus area of the right angle triangle. Okay, triangle. Area of the sector is half r squared, which is 12 squared, times theta, which is pi plus 1.231, okay, minus area of the triangle, which is half base, which is 4 times height, which is, or we can say half times 4 times 12 times sine the angle between them, which is 1.231, right? Okay, it will be to 1 decimal place 292.2, okay, squared meter. Okay, C, find the perimeter of the lawn in meters to 1 decimal place. Okay, to get the perimeter we will do the following. We will calculate the arc length APC and then plus this 12 radius, and then plus 4, which is 16, plus 16, and then plus the length of AD, which is square root of 12 squared minus 4 squared, or we can find it as 12 sine this angle. Both of them is correct. Okay, so first we should get the arc length now by the same, for the same angle. Okay, so the perimeter will be r, which is 12 times theta, which is pi plus 1.231, and then plus 16, 12 plus 4, 16, plus square root of the hypotenuse squared, 12 squared minus 4 squared. And the answer for nearest, for 1 decimal place will be 79.8 meter. Okay. Question 5a, find using algebra all solutions of 20x power 3 minus 50x power 2 minus 30x equals 0. Okay, it's very easy. 2x squared minus 5x minus 3 equals 0. And then we can factorize this bracket. Okay, it can be here 2x, and 1 times negative 3. Is it correct? Yes, x minus, right, equals 0. So we have the following roots, maybe x equals 0, or x equal minus half, or x equals 3. This is for part A. Part B, hence, find all real solutions of. If we compare between this equation and this equation, maybe the key is here, x. Look at x and look minus 30x, and look at the last term here, minus 30 bracket y plus 3 all power half. So maybe x will be y plus 3 all power half. To be sure, we can compare between the second term here and the second term here. If we square this expression, it will be y plus 3, right, as this. And if we raise it to power 3, it will be power 3 over 2. Okay, very good. So as we do this in the question, we can do this in the answer. By other words, the answer will be x equals 0 will correspond to y plus 3 all power half equals 0, which implies that if we're squaring both sides, it will be y plus 3 equals 0, and then y equal minus 3, and also y plus 3 power half equal minus half, but it can't be rejected. Okay, why? Because the square root can't be negative. Okay, finally you can write y plus 3 all to the power of half equals 3. Okay, squaring both sides, it will be y plus 3 equal 9, and then y equal 9 minus 3, it will be 6. So our answer is minus 3 and 6. Okay, number 6, the line L1 has equation 3x minus 4y plus 20 equals 0. The line L2 cuts the x-axis at r 8 and 0 and is parallel to L1. Parallel to L1 means it has the same gradient. Find the equation of L2, writing your answer in the form ax plus by plus c equals 0, where a, b, c are integers. Okay, first we want to get m1 for this line. To get m1, okay, we should put the equation of the first line in the form y equal mx plus c, or simply we should make y subject, right? So we can write it as the following, or for y equals 3x plus 20, and then dividing by 4, we have y equal 3 over 4x plus 20 over 4, which is 5. So the gradient here is what? Is 3 over 4. Okay, and it will be the same as m2 because L1 is parallel to L2, right? And then we have another information that L2 cuts the x-axis at 8 and 0. Okay, so we can write y equal m, which is 3 over 4x plus c. To find c, we have the point 8 and 0. And instead of y, we will put 0. And instead of x, we will put 8. 3 over 4 times 8. 8 over 4, 2 times 3, 6. Plus c, which means that c equals minus 6. So the equation will be y equals m, which is 3 over 4 x minus 6. And then to put this in the form, in the required form, we will multiply by 4 and make some rearrangements. It will be 3x minus 4y minus 24 equals 0. Okay, of course we have another method to solve it by this rule, y minus y naught equal mx minus x naught. Okay, the line L1 cuts the x-axis at P and the y-axis at Q. Given that PQRS is a parallelogram, find the area of PQRS. Okay, the equation of L1 is y equals 3 over 4x plus 5. We want to get the x-intercept, which is point P, so we can put y equals 0. If we put y equals 0 in this equation, we will move 5 to the other side with negative 5, and then multiply it by 4 and divide by 3. So it will be minus 20 over 3, right? Minus 20 over 3 and 0. This is P. And Q is the y-intercept, which is of course 0 and 5, okay? This is a rough sketch. Negative 20 over 3 approximately equal like negative 7, okay? And then maybe this is L1, this is P, and this is Q. And as the question said, point R is 8 and 0. 8 and 0 is here. This is R, maybe 8 and 0. And then we have PQRS is a parallelogram, okay? Of course, it should be down and by the same slope here, like this. This is the parallelogram, and you want to get its area, okay? Maybe the easiest way is to get the area of this triangle and double it, okay? It will be very, very easy because we have here R 8 and 0, and we have P negative 20 over 3 and 0. So this distance should be 20 over 3 plus 8. Okay, so I will get the area of a parallelogram as following: 2 multiplied by half base times height of this triangle. Base will be 8 plus 20 over 3, and then times the height, which is 5, because the Q has coordinates 0 and 5, okay? And the answer will be 220 over 3. Part C, the coordinates of S, okay? About the coordinates of S, we can solve it by several methods. We can solve it by using vectors, but I think it's very easy to do the following. L2 here, which is RS, has the same gradient or slope of PQ, so that we can say the following: how we can move Q, how Q can move to go from its place to P. It will go down with 5 units and then go left with 20 over 3 units. Can we do the same here? I mean that I will go from R to S as Q goes from its place to P. I will move 5 units down and then 20 over 3 to the left. This is 5 and this is 20 over 3 as a distance. So the coordinates of this point should be 8 minus 20 over 3, right? S here would be with x coordinate 8 minus 20 over 3. And of course the y coordinate is negative 5, okay? Which is 4 over 3 and minus 5, okay? Question 7. Figure 3 shows part of the curve C1 with equation y equals 3 sine x, where x is measured in degrees. The point P and the point Q line C1 and are shown in figure 3. This is P and this is Q. Okay, A state I the coordinates of P divide the coordinates of Q. Okay, very easy. Of course, we know that sine x or any angle should be between negative 1 and 1. And so that 3 sine x should be between minus 3 and 3, as we were multiplied by 3, okay? So that for this point, the y coordinate should be 3. We can look at this with from another point of view, which is we make a vertical stretch. So we will multiply the sine x by 3 to be 3 sine x. So for sine x, the maximum is 1. Now the maximum should be 3. Okay? What about the x coordinate here? The x coordinate, of course, we know that it should be pi over 2 or 90, because the question said in degrees. Okay? This is 90. What about Q? Let us complete the x-axis scales. This is 90, 180, and then 270 here, 270, and then here 360, and then I will add 90 here to be 450, and finally we have 450 plus 90, or we can say 3 times 180 will be 540. So the coordinates of P is 90 and 3. P will has coordinates, sorry, P will has coordinates, will have coordinate P, we have 90 and 3, and then for double I, Q will be 540 and 0. Okay, a different curve C2 has equation y equal 3 sine x plus k. Of course, we have here vertical translation where k is a constant. The curve C2 has a maximum y value of 10, okay? The point R is the minimum point on C2 with smallest positive x coordinate. Okay, state the coordinates of R. Okay, maybe the key point here is the maximum y value is 10, okay? So we can start from here. We said before that 3 sine x has maximum 3, but now we want to make plus something, and then the maximum should be 10. The maximum here is 3 and now is 10, so easily we add 7, and we should add it for all sides, okay? So I should add 7 here and also add 7 for minus 3 to be 4, okay? And this is the minimum value. This is the y coordinate of point R. What about the x coordinate? The question said smallest positive x coordinate. Okay, the minimum here at 270, of course. The first minimum point at 270. So simply we can say that R has x coordinate 270 and y coordinate 4. Okay. 8. The straight line L has equation y equal k multiplied by 2x minus 1, where k is a constant. The curve C has equation y equals like this. Find the set of values of k for which L doesn't cross or touch C. Okay, very easy. First, we will equate them. X squared plus 2x plus 11, which is y also, equals this y, which is 2xk. I will expand the bracket, 2kx, and then minus k, right? And then we can write it as x squared plus, I will take 2x as a common, okay? And then we will have here k, or we have here 1 minus k, right? X. And then plus 11 plus k equals 0, okay? In this equation, a here is 1, b is 2 multiplied by the bracket 1 minus k, and c is 11 plus k. And of course we should apply in the rule which say that the discriminant should be less than 0, because we don't have any point of intersection between the line and the curve, right? Okay, let us substitute now. Let us square b, which is 4 multiply the bracket 1 minus k all squared, and then minus 4 times a, which is 1, times c, which is 11 plus k. Okay, this should be less than 0. We can divide by 4 to simplify the calculations. So cancel this 4 with this 4, okay, and then expand the bracket. We will have 1 minus 2k, and then plus k squared, negative 11 or minus 11 minus k less than 0, and then rearrange it to be less than 0, right? Which can be factorized to be k, of course k minus 5 multiplied by k plus 2 less than 0, and then we can put these two roots in the number line, which are minus 2 and 5. If we will draw this parabola, it will be open upward, and we are searching for the negative part, which is here, of course, between the two roots. So k should be between minus 2 and 5. Okay. Question 9. A curve has equation y equals this, x is positive. Find the x-coordinate of the point on the curve at which dy by dx equals 0. Oh, very nice. Okay, first we must split this fraction into two fractions. I will write 4x squared, to be clear, 4x squared divided by 2x power half, right? And then plus 9 over 2x power half. This is y itself, okay? Again, try to simplify it as much as we can to put it in a differentiable form. 4 over 2 will be 2x here to the power of 2 minus half, which is 3 over 2, 1.5, okay? And then plus keep the coefficient here and then multiplied by x to the power of negative half. Okay, it's ready to differentiate now, okay? Y dash equals, we will multiply 2 times 3 over 2 to be 3 x to the power of half, and then plus, here the positive sign will be multiplied by the negative sign here to be negative, and then I will multiply 9 over 2 times half, which will be 9 over 4, and x to the power of minus 3 over 2, minus half, minus 1. And now we want to get to solve y dash equals 0, which means that I will take 3 over 4 x to the power of minus 3 over 2 as a common factor. Okay, when you find something like this, I prefer to take the denominator with in the common factor, and also x raised to the lowest power. Okay, and now we will divide 3x power half divided by 3 over 4x power minus 3 over 2. 3 will cancel 3, and down, down, up, it will be 4. Okay, x power half divided by x power minus 3 over 2. I will subtract the powers. Half minus minus 3 over 2, which will be half plus 3 over 2, which will be 2x squared. Okay, and then minus 9 over 4 divided by 3 over 4. 4 will be cancelled, and 9 over 3 equal 0. Okay, so x may be 0. I will take 4x squared minus 3 to be 0, which implies that x squared equal 3 over 4, positive 3 over 4, and here x equals positive or negative root 3 over 2, but I will take the positive only, root 3 over 2, because x is positive. Okay. Question 10. The curve C1 has equation y equal f of x, where f of x equals 4x minus 3 multiplied by x minus 5 all squared. Okay. Okay, sketch C1 showing the coordinates of any point where the curve touches or crosses the coordinate axis. Okay, first of all, we should look at the coefficient of x power 3. We have here positive coefficient and here also positive coefficient. So the positive, we have positive coefficient of x power 3. Our curve should be increasing and then decreasing and then increasing again. And also the curve should cut x-axis at 3 over 4 and touch it at 5, or we can say that it will rebound at 5. Okay. Also, it's important to get the y coordinate, the y-intercept, by putting x equals 0. If we put x equals 0, we have here minus 3, we have here minus 5 all squared, which is 25 times negative 3, negative 75. Okay, collect all these data and let us draw the curve. Okay, first indicate the points. This will be 0 and negative 75. Also, we have x-intercept here, 3 over 4 and 0, 3 over 4 and 0, right? Also we have 5 and 0, 5 and 0, and then draw the curve. It will be like this, okay? And make rebound here because we have power 2 in this bracket, right? B, hence or otherwise, I find the values of, of x for which f of 1 over 4 x equals 0. Okay, we are talking about what y equals 0, which is the x-intercept. The required is to know the new x-intercept with this transformation, and of course we know that we will multiply the x-coordinates times 4 by 4, right? Because we will multiply by 1 over 1 over 4, which is 4. So the required is to get x coordinate only, right? X, I will multiply 3 over 4 by 4, and also I will multiply 5 by 4 to be 20. So the answer of B, I, will be x equals 3 and x equals 20. Okay? Double I, find the value of the constant p such that the curve with equation y equal f of x plus p vertical translation vertical translation up, okay, exactly up, passes through the origin. Okay, it's very easy. I should move this curve vertically upward with 75. So here p should be 75, of course, right? This is the answer of double I. P should be 75. Okay. A second curve C2 has equation y equal g of x, where g of x equal f of x plus 1. Horizontal translation, and we will move it to the left by 1. Okay. Find in simplest form g of x. You may leave your answer in a factorized form. Okay. We will replace each x with x plus 1, just like this. This is f of x, and the required now is to get g of x, which is f of x plus 1. Okay, very easy. We will write it as 4 multiplied by x plus 1, close the bracket, and then minus 3, close the outer bracket, and then multiply it again by, instead of x, I write x plus 1, x plus 1 minus 5, but all squared. Okay. If we simplify it, it will be as the following: 4x plus 4 minus 3, which is plus 1, multiplied by x minus 4 all squared. X minus 4 all squared. Okay. Hence or otherwise, find the y-intercept of curve C2. Okay. Put x equals 0 here, and then it will be 1 times negative 4 all squared, 1 times 16. So I can write g of 0 equals 16, right? This is the y-intercept. 11. A curve has equation y equal f of x, where f double dash of x equals and x positive. The point P lies on the curve. Given that f dash x equal minus 4 at P, find the equation of the normal at P. Okay, answer in mx plus c. Okay, for part A, we have the gradient or the slope of the tangent at x equal 4 is negative 4, and of course the gradient of the normal should be 1 over 4 with positive sign. Okay, and then the equation of the normal can be found by y minus y naught equals m normal multiplied by x minus x naught. Okay, and then y minus 50 minus 50, it will be y plus 50 equals m normal, which is 1 over 4, and then x minus 4, right? And then we can be simplified to be y equals 1 over 4 x minus 1 over 4 times 4, which is minus 1 minus 1 minus 50, it will be minus 51. This is the answer. Okay, part B, find f of x. We have f double dash, and so that we should integrate twice to get f of x. But first of all, we must write f double dash of x in an integrable form. So we can write it as 6x to the power of what? Don't forget that we have x cubed here, but we have also power half because we have square root. So it's x to the power of 3 over 2 in the denominator, and in the numerator it will be x to the power of minus 3 over 2. Okay, and then plus x. We can integrate now. Okay, f dash x will be 6 multiplied by x to the power of minus 3 over 2 plus 1, which is negative half, divided by negative half, and then plus x squared over 2 plus c1, and we can write it in simplest form to be down, down, up. It will be minus 12 x power minus half, and then plus half x squared plus c1. We can use the information that f dash of x equals negative 4 at x equal 4, right? Or we can write it as following: f dash of 4 equal minus 4. So instead of f dash of x, I will write minus 4, and I will put x equals 4. So it will be minus 12 times 4 to the power of negative half, which it should be 4 power half is 2, but we have power negative, it will be half. Okay, plus half times negative 4 all squared, which is 16, plus c1, and this means that c1 should be what we have here: 8 minus 6, 2 to the other side, minus 2 minus 4, it will be minus 6. Okay, and so that we can write f dash x to be negative 12x power minus half and plus half x squared minus 6, and then it's ready to be integrated to get f of x. It will be minus 12 x to the power of half divided by half, okay, plus half x cubed divided by 3 minus 6x plus c2. Okay, simply it can be down, down, up. Also it will be minus 24 x to the power of half plus 1 over 6 x cubed minus 6x plus c2. We can use the information which say that we have here p of 4, we have the coordinates of p, which is 4 and negative 50, so f of 4 equals negative 50, right? F of 4 is negative 50, so we can write negative 50 here, and then we put instead of x with 4, 4 power half 2, 2 times 2 times negative 24, it will be negative 48, and then plus 4 power 3 will be 64 divided by 6 minus 6 times 4, which is 24, plus c2, and then c2 will be equal 34 over 3. Okay, and then f of x is completely found to be negative 24 square root of x, and then plus 1 over 6 x power 3 minus 6x plus 34 over 3. Okay,